If you have built any serious application with API powered LLMs like ChatGPT, GPT-4o, and all of these Anthropic's Claude, and there are heaps of others, then you must have noticed the pain of cost. Whenever you make an API call, it costs you few cents. And when your production load increases and you scale your application to service more and more users, the cost simply multiplies. More often than not, I have noticed that whenever your users increase, that is fine, but still they keep asking the similar questions, and you badly miss the need of a cache. That is where this GPT cache aims to resolve a lot of pain while saving you a lot of cost. ChatGPT and various other LLMs really are incredible when it comes to versatility, enabling the development of a wide range of applications. But as I mentioned, that as your application grows in popularity and encounters high traffic levels, the expenses related to LLM API calls can become really substantial and painful. Also, LLM services might show slow response time, especially when dealing with a significant number of requests, and then you might face throttling, blocking, and then your user experience will degrade. To tackle this challenge, in this video I am going to show you how you can install this GPT cache, which is a project dedicated to building a semantic cache for storing LLM responses. You can quickly try out GPT cache easily and put it into a production environment without heavy development. The installation is quite easy, and there are only 2 to 3 lines which you need to embed into your code in order to enable this cache, and I will show you shortly in the code demo too. Also, this project is quite new and under very heavy development, so there will be a lot of changes, lot of issues you will face, so don't worry about it. You can just open an issue with them. Plus you can also wait until they support more and more API provided LLMs, or maybe even local LLMs, who knows. The only prerequisites which you need in order to get it started is to have Python installed and make sure that you're running Python version 3.8 and above. I will be using it with OpenAI because that is the mostly used LLM provider out there, and that is what it supports at the moment. So you would need an OpenAI's API key in order to get started, which is a paid option. And for that, you would need to go to platform.openai.com and grab your API key from there. And I'm also going to drop the link to this GPT cache repo in video description. Feel free to play around with it. Before I show you how to get it installed and show you how to enable cache, let me give a huge shout out to Mass Compute who are sponsoring the VM and the GPU which I'm using for this video. If you're looking to rent a GPU on affordable prices, I will drop the link to their website, and also I'm going to give you a 50% discount coupon to get started, and 50% coupon will give you discount on range of GPUs. And this is my Ubuntu system, the VM which I'm using, and we will be using this NVIDIA card, which is NVIDIA RTX 6000 with 48 GB of VRAM. Of course, you don't need that much VRAM for this demo because we will be using API powered LLM. Let me clear the screen. Let's install few of the prerequisites. I will be showing you the demo in the Jupyter notebook, but for the purpose of this, I'm just going to install a Conda environment here. I'm just calling it Gcache with Python 3.11. Let's wait for it to get created, and it will keep everything separate from my local installation. So let's wait for it to get installed, and that is already done, which is great. Now, next step you need to do is to make sure that you have grabbed your OpenAI's API key. If okay, sorry. So if you have, simply put your OpenAI's key here in this format, which I'm going to show you now, and then just enclose it in double quotes. So let me put in my OpenAI key and then clear the screen. I have set my key in the environment variable. Next up, let's install GPT cache, and for that all you need to do is to run pip install GPT cache, and it is going to install it locally very quickly. It's very lightweight, and that is already done. Let me clear the screen. Okay, so that is all done. Let's now install our Jupyter notebook, and then we will run it in the browser. So let me first install it by just doing with conda install Jupyter-y, and that is going to install that Jupyter notebook here. So let's wait for it to get created. Shouldn't take too long. And that is done. Let me now start that Jupyter notebook. It is going to start it in my browser. Okay, let me clear the cache here. Sorry about that. And now just to tell you what exactly that error was. So this is a bug with Jupyter notebook. Sometimes it just messes up with char set. So for that, all you need to do is to just first uninstall it by using pip uninstall char set underscore normalizer. Once that's done, you can go back and install it like this, and it is going to install it on your local system. That is done. And now when you will run your Jupyter notebook, it should start it on your browser easily. There you go. So let's wait for it to get started. That is done. Let me open it, the new notebook here. And now we are all set here. Okay, cool. Now if you look at this code is simply loading the environment variable. It is initializing the OpenAI's instance, and then it is making an API call to OpenAI without using any cache. So let me first quickly run it, and then it is going to show you the answer. And don't worry about the prompt. We are more interested in this time consumed. So it has taken around 1.88 seconds. If you will run it again, it is going to go to again OpenAI, and then it is going to return you the response to the same prompt. The response might be different because it is LLM. You can fix it by using temperature to 0, but you really don't want that. For example, if your thousands of users are using the same question, you don't really want to make 1,000 API calls to OpenAI. You just want to make one call and then cache the result. And you can do that by GPTCache by using this code. Now, if you look at this code, let me go slightly above there. So we are importing time. Then I just defined a function response, then cache loading, and these are the two lines which you just need. That is all you need. So we are importing the cache from GPTCache, we are initializing it, we are setting our OpenAI key which we have defined above, and then you can ask it a question, and this is the same API call which you will make, and then you can print out the response. So let me run it quickly, and you see, so it has loaded the cache, and then it has given you the response about GitHub. Now, if you run it again, it is not going to go to GitHub, OpenAI. It is just going to return you from the cache, and you see, even less than 1 second was the response. How good is that? So this is the beauty of this GPT cache. I'm very, very excited about this tool because this is going to save us some serious money with a lot of API powered projects. And now let me show you another extremely important feature of this GPT cache, that if you look at this code, what it is doing, it is enabling you to return the response. If I just go down and I'll show you. So for example, you're asking similar questions from this model, like what's GitHub? Can you explain what GitHub is? Can you tell me more about GitHub? What is the purpose of GitHub? Now, instead, these are all similar one. The answer to this question is same. So instead of going for all four questions to your API provider, it is just going to go there once. How good is that? So that is also another beauty of it. So let me run it. And there you go. So it has just converted it into one question and returned you the answer from the cache. So all in all, amazing tool. Also, if you want to bypass a cache, there are few ways which you can do it. For example, you can always pass a parameter of temperature while requesting the API service or model. A higher temperature means a higher possibility of skipping cache search and requesting large model directly. When temperature is 2, it will skip cache and send a request to large model directly for sure. When temperature is 0, it is going to search cache before requesting large model service. So amazing stuff. And as I said, there are few other features. Project is evolving, so keep an eye. and I will drop the link to it in video's description, and you can find these code chunks also on their GitHub repo. If you like the content, please consider subscribing to the channel, and if you are already subscribed, then please share it among your network as it helps a lot. Thanks for watching.